So I'm not really. I feel like the logical order seems to be related a little bit at least. So maybe I want to talk about 1 point. Something pretty cool there. So if you have a triangle, right, and you have a point P inside the triangle.
Oh, Petal Triangle. So. Is it? I don't know.
You can define the Petal Triangle with respect to P. Okay. So what you do is you take the perpendiculars.
Yes.
Oh yeah.
Okay. And then yeah, so the Petal Triangle is defined to be, you take a point inside called P, the Petal Triangle of P, you take the perpendiculars to the edges of the triangle. Okay. And you might want to label these like so the way it's labeled, like A prime, because to the one opposite A, you could do C prime for the one opposite C and B prime for the one opposite B. Okay. And the Petal Triangle is just A prime, B prime, C prime. Okay. So I think we've already seen, like, can you think of an example of a Petal Triangle we've seen?
Orthic triangles.
Huh?
Orthic.
Orthic triangle. And why is it a Petal Triangle?
Because like they meet at the same point. It's an orthocenter.
Yeah. So if you take P to, it's like you take an acute triangle, right? And you take P to be the orthocenter.
Take P to be like the in-center.
In-center.
No, that's it's the in-center of, like, it needs to be perpendicular. So the orthocenter is the in-center of the orthic triangle.
Like if you take P to the in-center, then you also get a P triangle.
Take P to be the in-center. Oh well.
You get like a.
I mean, it technically works. So
You get like.
you got an equilateral.
Yeah.
Oh wait, do you? No,
you don't.
You just get like.
I know.
Like in-center is just kind of like.
That means like P is a circumcenter of like A.
Yeah.
In-center. It's a Then yeah, it's a circumcenter of A prime, B prime, C. If P is the in-center.
Yeah, because like A prime and C prime are all like in circles, so it kind of
Right. Yes. So if you take 3 points,
Yeah.
but then it's the circumcircle of that circle, right? That's kind of not really a way to define something. So yeah, if you take the in-center, I guess you do get something. The question is it something we already know? Okay. Yeah. All right, but we definitely have seen examples of Petal Triangles where this is the orthocenter. Yeah. Okay. So I guess one thing you could notice is that A, B prime, P, C prime is cyclic.
Yep.
Yep. And the same for the other.
Yeah.
This is the diameter. Right? All right, so I guess one of the facts you can prove that's a theorem. I want to actually state out of order because I think the next one is probably cooler. Okay. So the thing I want to state, okay, is it's pretty cool. It could be an exercise, a theorem. So if you take a petal triangle, right?
Yeah.
So you take a point P, yeah?
Yep.
Make a petal triangle. This actually isn't trivial to do. It may fail. Okay. And then you'd use the point again to make another petal triangle.
Oh,
Okay.
oh god. Well, then it's similar to like the first one, is it?
Well, you know the answer.
Do I kind of guess.
Yeah, makes sense.
Yeah, actually, maybe that's why one of the previous sections might be useful to motivate that idea. But okay, so you get another triangle, yeah?
Oh,
You see it?
yeah.
Okay.
And similar.
Do it again.
Huh?
Okay. So it's the third petal triangle. So that's the first.
Yep. That's
Maybe that's the 0th. No, I don't know. Okay, this is the first. This is the second. And the third one. I don't know if you can see it now, but do you have another color?
Orange.
purple.
Purple. No, that's not good enough. Red.
Where the other is orange.
Okay. Alright, if we draw this successfully, we don't even need to erase it. So maybe I'll do the next one. Oh.
Oh well, red. I don't know. We're using red stuff. So
That's green or red?
Green or red?
Yeah.
Alright, give me both.
red. Yes.
I don't blue a lot.
Oh yeah, let me try that. Blue. Green. So is that yellow visible or not?
Kind of. Maybe good, but
No.
Is that better?
Much better.
Oh, the hiccup made me lose my aim.
Oh, maybe he has no straws.
Can you see that?
Yeah.
So that's the third petal triangle.
Oh, which is similar to the first.
Yeah.
I see.
Third, similar
hang on.
to ABC.
Okay, that's
Maybe you guys can prove it.
Sure. Oh, I. Let me see. Oh. Oh no.
Or at least think about it, and I'll give you a hint. Yes, this is ABC. I mean, the fact that someone thought of this is pretty cool.
yeah, someone like
I mean, once you
Normally-
have it there to prove it, it's kind of maybe easier to prove.
Yeah.
But like, just this,
starting from it, it's kind of
yeah, it just has this sort of, it just reeks of imaginative.
yeah. Because most people will like stop after like the first or second one. Like you might do it like once and see what happens.
Determination.
So you keep doing it, right? And then you keep getting similar triangles.
Probably not.
Yeah, but then if you just do another 3 times,
What if the first two aren't similar? I don't know.
Oh, I could, yeah.
Right.
I'm gonna do it first time and see what happens.
Can you see it's kind of possible to always make the first one not similar to the big one?
Yeah.
Because you can kind of pick the point
You just pick
Sort of
a random
at a point like where the angle's definitely not
Yeah.
the other three. Oh, my hiccups endured since yesterday.
You should buy a straw.
Uh,
I'm starting to see why.
Who the hell uses a pen T as a ruler?
I'm starting to see why this would work.
oh, it's interesting. What do you think of the cyclic for? I'll give you a hint in 1 minute.
I just realized that small triangle also has these cyclic triangles. Will that help?
Yes.
Save that didn't help.
Oh, it's a very good psychological insight. I wonder why I wrote cyclic as one of the properties.
Oh crap, I don't have a ruler. Well, I'll just big eat it. Ten, 15, 12, 13.
Like, this is one of the things. It almost is like a flagship for maths. It's like you don't necessarily care that it's some like applicable result. It just kind of feels cool.
Yeah.
Maybe in the end, it's still useful to solve lots of problems.
These triangles so misleading.
All right, so here's the hint. Think of this dotted line here. Do you see that?
Yeah.
Connects to P. Okay.
Make some. Wait, that means some angles are equal.
And then angle change these two angles.
Yeah.
Angle changing. What?
I mean, in all fairness, you probably didn't get enough time to think about it. But I could have also just given you the solution straight away.
Yeah, I got it.
Oh, nice.
Yeah. Because I did it the first time, and then
Oh.
because I connected that with the second.
Oh, okay. So,
Yeah.
so
After you do it first time, you start realizing like how it might work because it's just rearrangement of.
yeah, I guess did you think of the one with the orthic triangle? Because it was kind of, it was a bit of because you know how you saw those angles were equal. for
Oh
example?
yeah. No, I just kind of just thought about it. And,
Okay. All right, guys. Listen. So this angle equal to that angle, right? Because they're on a circle. This big open circle is equal to this angle here, yeah? You see that?
Oh, okay. I see.
It's kind of cool. It kind of makes its way inside the triangle into the next one.
Ah, okay.
So, like, what's the next one, you know?
Just do the same for all the other.
Yeah. So you kind of got to be a little bit careful. So that there's the next one going here.
for
The
dot.
dot.
Yeah.
Dot goes here, right?
Hmm.
You see that?
Yes. And then dot goes down there.
And then open circle.
Open circle goes.
Open
Open circles goes to like where the right angle is, like where it looks like the right angle.
here.
Yeah.
So the open circle goes here, right? Is that right?
Yep.
Yeah. Yeah, and so now open circle goes in here, right? Yeah?
Yeah.
I mean closed circle.
Closed circle, yeah.
And then open circle goes in here.
Yeah.
Alright? Can you even see that?
Maybe like just redraw it again with those two angles over there.
Yeah, so basically draw the big diagram, connect this line and chase these two angles.
Yeah.
And you'll see that the top angle A is sort of equal to the bottom angle of the middle triangle. Okay? And so by some sort of symmetry, then all the angles are equal to one of the. Yeah, so yeah, that's pretty awesome.
Yeah. Third one.
The third petal triangle. The third petal triangle is similar to the original triangle.
Yeah.
So for any, it seems to be any point inside. Yeah.
Yeah.
So I guess this was traditionally an exercise. So it attributes this. I don't really like to attribute too much stuff because it makes me pretend I know people. But someone attributed this to an editor of some John Neuberg, but it just said it was first appeared as in that thing that he did. Okay. Yeah. And then this got generalized. So I didn't look this any further. So in the 70s at the time, this got generalized to an n-gon has the nth pedal
Inside the
n-gon is similar to the original n-gon. So maybe you could write as an exercise to check it for quadrilaterals.
Oh.
It's like the fourth quarter, but not right now.
Yeah, just write it up.
The fourth pedal quadrilateral is similar to the original quadrilateral. And this person apparently was some guy called B.M. Stewart in 1940.
BM long.
Yeah. Okay. Okay.
You're telling me that green triangle is a bit similar to the big triangle.
Huh?
Like little green triangles.
Yeah, the little green triangle is similar to the big black triangle.
Wait,
yeah,
with the
sure.
quadrilateral, because if you do it like 4 times, because for similar quadrilaterals, ratios of the sides have also to be the same. So
Yeah, the angles are not enough.
yeah, it's not enough to have anything.
What happens if it's square? Then which one?
Because square, if the angle, just because the angles are the same, they might be like square is
Always the rectangle.
squares are
Yeah, so that's an example, counter example, right? Like,
rectangles. Yeah, square rectangles.
they're not similar.
You don't even get a kite.
But square, like if you do that, it's
All squares are similar.
No, but like the
Yeah, so I guess for a square, you're saying that you get a square.
Yep.
Maybe we can try it.
just put at the center or what?
This is not a proof. This is actually literally a sketch.
Yeah.
Square. Take it. Oh, it's too close to the wall.
Yeah.
What? Does that even make sense anymore? I mean, like, it's really easy to draw like these.
To draw the first one is
That's gonna get real weird.
Pen color change time.
yes. Oh wait.
Oh, my hiccups is making it hard for me to
Draw.
like lines.
Just stretch the line out. Well, what will I do? Wait, never mind. I thought wrong.
It's two. We got 2 more to go.
No.
We find the angle for this first and then do it.
She was like, I can't wait to the 4th one. I'm gonna use the.
I don't know how.
Alright, blue pen time.
And finally, big brain time.
Oh man, the hiccups.
What? It just goes so confusing.
We're not done yet. 1 more to go.
What the hell?
Does this really end up as a square?
Does it?
Does it?
It doesn't look like it.
I mean,
Well, like I pick up like six times during.
Oh,
this
it
run.
might be. It kind of does.
I'm gonna use a big. I'm gonna see if this works.
Oh,
Do the huge square.
ugh. Oh my gosh. It actually looks like a square.
Oh my god.
But who knows? It might not be a square.
But like the others are so far removed from looking like a square
Yeah.
that it's kind of crazy. That looks like a square.
Yeah.
But your first instinct should, like, I guess, I don't know, like maybe your very first instinct, if you just saw this on its own, that it's hard to prove.
Yeah.
But if you just saw the proof of the triangle one,
Yeah.
you might not fear it.
Yeah.
I don't know. Didn't look into this. Yeah, so some of these parts are going to really let my insights because I haven't looked into it very much further. Yeah, that's a cool picture. I'm glad we have the pens to do it. Okay, so I stated the things out of order. Okay. So I basically started with the very last part of the last thing.
Oh.
The part that was just before it, 1.9.1, was saying that basically you can relate the so we have a petal triangle, right? You can relate this length we call A, right?
Yep.
To this length, which I guess we call B dash C, B prime C prime.
Are they parallel? Depends.
No, they're not.
So if this was the midpoint, then yeah.
Yeah.
See? Okay.
So you can relate that.
Really, what to what?
So we're relating
Sides.
B C prime to A
Okay.
Well, sure, let's see. That's
Yeah.
true.
in terms of
Oh.
in terms of PA. And-
Wait, B prime, C prime, or just B, C prime?
Sorry, B prime C prime. Yep. So like actually,
Sine.
yeah. So and it's gonna involve AP,
Yeah.
right? And the circumradius.
Seems legit.
Yeah.
Circumradius.
Circumradius. Yep. I see.
What? Oh, like the whole triangle. Wholly.
Yeah.
Well, that's just got confusing real quick.
Yeah. So maybe like just to remind you, remember the sine rule we had with the circumradius?
Yep.
I mean, just to remind you of it, right? Let's apply it to So we have
Oh, okay. Yeah. I
B
see.
prime C prime, right?
Yeah.
Over sine A, yeah.
Yeah.
Okay. I mean,
That's
if you remember the rule, yeah,
This equals 2R.
AP.
then it's equal to 2R of this circle, right?
Yeah,
Yeah.
but like, wait, that passes through, which means it's equal to AP.
Yeah, that's the diameter, right?
Holy.
So it's equal to AP. So if you remember the result,
Yeah.
then you know that's the extent of
Yeah.
floor of sine, right? If you don't know the result, well, just draw the angles in. So you draw the angles in. It's equal to this sine, sine dot. So this normal sine rule, right?
Yeah.
PC prime over sine dot, yeah?
Yeah. Oh.
Okay, but sine dot, this is a right angle now, yeah?
It's PC of AP.
It's PC over AP, right? So it cancels. It's a PC prime. Anyway,
Which is equal to AP.
yeah, but we proved it again. We don't have to prove it. And maybe similarly, BC or A, little a, over sine A, right, is equal to 2R. Yeah.
Oh yeah.
So therefore, you can eliminate sine A from both
in
of
terms
those.
of, and then you set it in terms of A to R and AAP and
Yeah.
R.
So you can just like divide the two, for
Oh.
example. So B prime C prime on A, right, equals PA. Let's say
PA.
wrote it backwards.
PA onto R.
2R, yeah.
Oh. Yeah.
Okay. Yeah.
Right, that's cool, I guess. Like, what if it be denoted at all?
Yeah, so this actually came first in the theory, okay? But they don't make any mention of it at all in the second part.
Oh.
But I think it is related. It is slightly related. I mean, first of all, it shows us, so remember one of the things we naturally thought, we thought the first triangle could be similar to the big triangle,
Yeah.
right? But this, can you see that this shows it's not?
Yeah.
Right?
Yeah.
Well, not necessarily. So basically what this is saying is that basically the ratios depend on the distances between the point and the vertices.
Yeah.
Right? So this works for all three, obviously. Obviously, like,
Mhm.
this is just one of the sides, but
Yeah.
all three can be,
Yeah.
with little b, it's just capital B there. Right? Yeah, maybe I'll state this theorem more like how they state it. So the theorem says P inside triangle ABC, and say like X, Y, and Z are the distances PA, PB, PC, right?
Yeah.
Then, what does it say? The ratios of the sides, basically, so it's AX on 2R,
Mhm.
BY on 2R, yeah. And CZ on 2R. They're the side lengths of the triangle.
Oh.
See, because that's A times X on 2R, right? We following?
Okay.
Yeah. So can you see there is one case that it is similar, right?
Yeah.
What's that?
Oh
Well, if X, Y, and 0 equal, right?
yeah.
Then the ratios are all the same. right?
So that's when it's the circumcenter.
So that's when it's the circumcenter. Oh, yeah.
And then that makes sense as well.
What makes sense?
Like if you have it, if it's a circumcenter, then there will be someone.
Of
course.
Oh. Okay.
If it's the circumcenter, wouldn't it be like, wouldn't the Petal Triangle be the Medial Triangle?
Yeah.
Maybe
So-
that's why it's first.
Yeah. So I was gonna say that in another part, but yeah, I'll explain a little bit about how that's related. Yeah. Yeah. So I guess it's. I found it strange how there wasn't a mention of this corollary, which is like. Can you see like an obvious corollary?
Really, what?
Corollary just means like easy consequence. Like it seems like I don't know. Maybe I don't know why they don't state it. Maybe it's just not interesting. But like, well, the second petal triangle, the side is going to change to A times X times PB prime, right?
Oh yeah.
Over like 4R and then the next R. I guess. So if you apply this 3 times, right,
Oh, yeah.
you'll get 3 side lengths, right?
Mhm.
And because it's similar, the ratios should be equal, right?
Oh
It's not stated. It's not even mentioned. But
yeah.
I think
like I feel like if you do like 3, then it becomes
yeah.
What is
Yeah, I guess it's making sense of what the formula is. Yeah. But this I feel like there's a bit of a knack for not talking about stuff relating to other stuff in this one. Alright. Yeah, I guess they're the only points I wanted to make. Let's see. Yeah, okay. Okay, so that's 1.9 done, yeah? And we did it before, 1.7 and 1.8.
Medial Triangle.
Medial triangles.
Oh.
Okay. So, do you know what the definition of a medial triangle is?
You did a median today.
Yeah, so you take the medians of these points and you connect them. Yeah?
they're parallel.
Oh, yeah, that's a good observation. Yeah, so we
Are they?
talked about that, yeah?
Oh, yeah, sure.
Alright. So, this is a medial triangle. Medial triangle. So, you connect the medians. Okay. Is it pedal? Medial triangle's pedal.
Are they?
So like you're saying if
Find them. Okay.
Whatever that means.
Yes,
Wait, really?
because that's the like perpendicular bisectors. So that's just circumcenter. Where like
I mean, that seems fair. I think it is.
Yeah, so that's a really good idea. Yeah. Where's the pen? Yeah, so if you took the perpendicular bisector, right? So basically, if you took the circumcenter and made the petal triangle for the circumcenter, yeah, that will give you the medial triangle. Yeah, I guess it's technically not correct, but mostly correct.
Yeah.
because the circumcenter might not be inside the
Oh,
triangle,
yeah,
right? And the petal triangles have to have the points inside.
Yeah, I was just like seeing. I
Yeah.
just noticed that. Yeah.
But the major idea here is that it could be a petal triangle, basically, yeah? Right? Okay, so you already see that. Yeah, what else do I want to say about this? Yeah, maybe I'll add this in just. Do you guys still remember what the Orthocenter was?
Yep.
Yeah.
Orthocenter. Okay, and then maybe I'll say O.
Circumcenter.
G for centroid. You remember what that was?
Centroid. Centroid is for the median.
Center of mass.
Where are the medians? It's the intersection medians.
Yes, where would these medians meet, right?
Yeah.
Okay, and then there's the circumcenter, yeah? Let's call it O.
Yep.
Yeah?
Yeah.
So the cool thing is they're collinear, okay?
Oh, yeah.
Yeah.
I think of
And then I can't remember if it's 2 to 1 or 1 to 2, but we'll check it later.
Yeah.
The ratio. And the line is called the Euler line. Yeah.
Yeah.
And I guess we can kind of slowly work our way up to that. Yeah. But I don't want to like randomly say facts and then throw a punchline at you. That's what we're going for. Okay.
What about incenters?
Huh?
Incenters.
nah.
Oh.
Oh, mate. Probably not.
Yeah, I mean, we have some facts that say like the incenters equal something of the something. But I've kind of forgotten them right now. So, but we can consolidate this a little bit later because we still like, even though we're covering all the rest of this chapter in theory today, there's still tons of exercises, right?
Okay, one lines equal.
Oh, this hiccups.
Is incenter spelled with the ER or RE?
Oh yeah.
And then
This
also
is-
center spelled with the RE, but like.
So at some point,
Yeah.
Not
I.
Is that RE?
It's ER.
it's funny. It's one of those problems I always worried about but never resolve.
Incense. Sure, ER.
And then
Incenter is both.
I think it's easier to write the ER, so I just went with the ER.
No, but ER is like center.
So it's RE.
Yeah, it's obviously.
No, but R is like.
I know, right? Oh, so why also center spelled with the RE?
Oh, is it?
Yeah, I think I'm pretty sure all the center. Also center, I'm pretty sure. it's
Oh, did I
RE.
naturally write RE for Orthocenter?
Yeah, I'm pretty sure that's why I'm like most of this is true.
Yeah, because it's not like the same.
It sounds about right. Yeah.
Yeah. Oh. Yeah. Well, if you don't understand what I'm saying and you only can see these words, you'd think I'm retarded.
Oh, my eyes are hanging looking at this thing. Right.
Okay, so what is the next fact? Oh yeah, so the next fact's, I guess one of the motivating reasons for why we'd ask if the first petal triangle was similar to the whole triangle, right? Because in this situation, can you see that this triangle is similar to the big triangle?
Uh-huh.
Is that obvious?
Well,
yeah,
you
the
said
half-
you
the
said
half.
it's half, right? So
They're all half the length.
Yeah, so this is half the length of that.
Yeah.
yeah, that's just like 2 dash. Two.
Yeah. Okay. It's parallel.
Yeah, and it's
Yeah.
the circumcenter, remember?
Yeah.
It's actually that case,
Oh yeah.
right?
Yeah.
Yeah.
Or
Right?
Yeah.
So it's actually that case that they're similar. And it's half, right? Because we even have that
Uh-huh.
result.
Yeah.
So this actually came first. So, I mean, I'm doing it in a different order, but I think it's more interesting
Oh,
this
this
way.
is this into 4 equal triangles.
Oh.
Yeah.
How'd you know that?
Because like this is
Well, now we know. Like,
there's
no.
3 and this is 1.
Yeah.
Yeah, that's how
Four congruent triangles.
Because I thought first of all like the area would be 1/4, right? And then it's
Oh
like-
yeah.
Yeah, the area is 1/4.
There is 1/4.
Like we knew that the areas were equal from before.
Yeah.
Well, actually, did we?
No,
No, it was the other way, right?
Yeah.
So be careful. So it was the one with the Sevians, yeah.
Mm-hmm.
This is with there's
Yeah.
no lines going from the vertices.
Oh yeah, like you know that all of those triangles are similar to each other, similar to the big one because they're
and similar by
right?
half, yeah.
So they're all gonna be a quarter. So
Yeah.
the middle must be a quarter.
Like you can just show in
Yeah.
things so it's nicer.
Yeah. Okay, so I guess you can. Yeah, you maybe want to join in. Yeah.
Mm.
This is 1, 2, 3, right? So they're all congruent.
Mm.
Yeah. Can you see that? Let's see which one we want to see. Oh, maybe I'm in need of another diagram. AC prime, AC prime, A prime, B prime. So this thing here
AC. Okay. There's parallelogram.
is a parallelogram. Yeah.
Yeah.
Okay.
Opposite sides are equal.
Yeah. So the opposite sides are parallel and equal. Yeah.
Yeah.
That makes it a parallelogram. Yeah. Well, the opposite sides are parallel. So, what does that mean? I guess maybe we're at the extent of this diagram. We might have to draw some more things in. Yeah.
Yeah.
Let's see, what is the diagram? Yeah. Okay. So I want to join in. I want to join in the line from A to A prime. Yeah. Okay.
Oh, so they're all in line.
Yep.
Yeah.
Oh, the
So-
actual medians.
So the A to A prime is a median, right?
Yeah.
And it bisects B prime, C prime. Is that obvious?
Yeah.
Yeah,
it does.
yeah.
Because the parallelogram has diagonals
That bisect. Yeah.
bisect each other, right?
Because it's parallel.
So I'm running out of symbols to denote equality, so maybe I'll just leave it for now. Okay. What's my next claim? Oh yeah, I think I already talked about this at some point, but does this, can you see that this shows that, did I talk about this? That remember how I said if you had the centroid,
Yeah.
right? Remember you had the centroid, so I'm trying to say the centroid of the centroid. Wait, what am I trying to say? Is it the centroid? Yeah, so when we just normally construct the centroid, right?
Yeah.
You also get that triangle, yeah?
Yeah.
Like the normal way to get the medial
That's-
triangle,
yeah.
Remember how I said, well, those points are also concurrent,
And,
like the Sevians, they're also concurrent.
yeah.
What's the reason that they're concurrent?
Is the area the same?
And it's because they're also the medians, right?
Yeah.
So can you see that if you look at the triangle inside, right?
Yeah.
The red line is a median to the piece because it bisects it. It's a median, right?
Yep.
Does that make sense?
Alright.
So the median of the A to BC is also the median A prime to B prime C prime. Yeah?
So,
Oh, that makes sense because similar triangle.
Yeah, it's kind of like if they're similar, then the sort of important
'cause-
things are meant to be
because
equal, right?
because if C A prime equals A prime B, then B, and that's
Yeah.
going to be bisected.
Yeah. So basically, the conclusion that it's like more like revision, right?
Yeah.
So the centroid of the small triangle, the medial triangle, right, is equal to the centroid of the original triangle, right?
Oh, yeah.
That's what we're saying.
oh yeah, okay.
All right. Good. And is it clear that the so maybe I'll write that down, yeah? Centroids of ABC equals centroid medial triangle. Yeah. I guess because we're trying to talk about the centroid, right?
Yeah.
Of the big triangle. Now we can basically talk about either centroid, it's the same, yeah? Okay. That's good. Okay, the next one is the orthocenter of the medial triangle. Does that make sense?
Mhm.
So you take
Wait,
the
the Euler
altitude.
line is in the medial triangle only? Or is it in any triangle?
Oh no, the Euler line applies to the ABC.
But like,
Oh,
we're just talking
okay.
about something else.
Yeah, the centroid is for the ABC. The orthocenter is for ABC,
Okay.
and the circumcenter is for ABC. But we're kind of relating it to the things in the medial triangle as well. So we're saying the orthocenter of the medial triangle. So it's not H anymore.
H prime.
Yeah, maybe we call it H prime. Yeah, that's a good notational instinct, algebra man. Okay, is equal to. You see what it's equal to?
Oh, it's equal to the it's equal to the circumcenter
Oh, the circumcenter, huh?
of ABC, pretty sure, because they're parallel lines.
Oh, okay. So it's equal to O. That's what you're saying, right?
Yeah.
Yeah. So the orthocenter of this triangle is equal to the circumcenter of the original triangle. Okay, because first of all, to get an orthocenter, you need a height, right? Use what color should I use? Red, black, blue. Yeah, I've never used multiple colors for anyone else, people. All right, so let's see. Okay, so we have this it's altitude, right? Yeah. So basically, can you see that because these two lines are parallel, right? And that's 90 degrees, this has to be 90 degrees. Yeah? Co-interior angles. So that means this is the perpendicular bisector, right?
Oh, okay, yeah.
Yeah, this is starting to make me think this applies only to acute angle triangles.
Yeah.
But it might be an exercise or something that says it also applies to obtuse angle triangles.
Oh.
Okay. Okay. Yeah, so what have we said here? Another way of saying that G prime equals G, right? H prime equals O. Yeah, sometimes finding the right notation to express it is also like a revelation, because you're relating the ideas to things that you already have. You don't have to create new notation.
Yeah.
I think he's up to something.
Huh?
Is that like part of the proof of like this Euler line?
Yeah.
Oh yes, HOG.
Yeah. Okay. Do I need to draw more stuff in? Let's see. Okay. Let's have a look. What's a good thing to draw in? Okay, so this is gonna be weird because my thing seems to be on the other side of their diagram. Okay, let's try to draw a big altitude. It's hard to really find a right place to draw an altitude, but let's try one here, okay? And then make this altitude here. And hopefully it doesn't intersect too many things accidentally. Yeah. So this point here is H, right? Yeah?
Yeah.
Okay. So where is all the other points? Let's see. So O was
It was where the green did.
Green dot at once.
was it?
Yeah.
Yeah. It's like a O that's covered by a line.
It's the
Oh,
because
right.
it's where the
Is it?
yeah, because that's the perpendicular bisected.
Oh,
Because we know that oh yeah, because we know that H prime. Is
oh, we drew the bisect perpendicular. Yeah, okay, that's right. So O is the green dot, yeah?
Yep.
That's O. Okay, good. And then what's the other thing that we care about? G, right?
Mhm.
So G should be in red.
Yep.
Oh jeez.
It's the one. It's the one that was like. It's the intersection of the blue and red.
Okay, let me see what triangle we need just so I don't draw a long line. So we need HAG and OA prime G. H A G. And what else? OA prime G. OA prime G. Maybe I'll just, let's see what happens, okay? If I connect this, okay? And that's G, yeah? Okay. So where is HAG?
AG.
Oh, this is a problem. My diagram's not good.
Yeah. I think like
Because
redraw
my
it.
G is not meant to be like on that side of.
Maybe redraw the diagram like bigger.
Yeah, now that we know the characters of the story, maybe we can redraw the diagram, yeah?
Yep.
Alright. Agreed. And then let's remember that H prime equals O, G prime equals G, yeah?
What about O prime?
O prime's not needed. It was a good while it lasted.
Yeah, it was good while it lasted. But see, small diagrams are not good. This is but they're easy to draw. Okay, let's have it leaning that way like them. I guess the big one doesn't need to be that solid. It doesn't. Okay, so take the midpoint. Yeah, we don't need to mark those midpoints in. That could save us some trouble.
Yep.
And then That's O, yeah?
Yeah.
Okay, I'm not even going to draw O. Okay? Maybe I start another color. Okay, to get, maybe I'll do green for H, yeah? Oh, gosh. That's H, yeah?
Yep.
Oh. Then I'll draw these two medials. Oh, this is working out well, don't you think?
Oh yeah. Well, it's a lot like Kiro.
Gee. And the idea, well, give me a black punchline pen here. Is that, I don't want to actually draw the line
Yeah.
because I'm going to ruin the diagram and then it's going to be impossible to put.
Oh wait. Wait, is that bad?
Well,
Because if they're comedy, you're trying to prove the angle is 180, right?
oh yeah, so probably should. So the way that they prove it is they show these two triangles are similar.
Oh, wait, which two?
So it's HAG. So
Okay, yeah.
how should I denote this? Maybe I'll draw in A. Yeah. I'm getting a bit overconfident with the diagrams. I'm going to mark in H.
Yeah.
G.
G is the red one.
Yeah.
Yeah.
Okay. So maybe I can sort of start a line going. Yeah.
G should mean it's green, but it's red.
Huh?
No.
Oh, G for green. And then that's O, right? And there's O, A prime. So this is A prime.
O, A prime, G.
This is O. So
A prime, G. Okay. I'm guessing they asked for O, A prime, G.
we have to do some.
Yeah, wait, no, if you do it, it's obvious.
O, A prime.
G.
Yeah.
Oh, okay.
Yeah.
Still, I think. Yeah, and then, well, what's the significance of drawing this?
Oh, so basically the proof. I mean, I'm probably sure there's lots of ways, but if you show those two triangles are similar, right?
Yeah.
Without showing these two angles are equal,
Oh.
the conclusion is these two angles are equal.
And
therefore that has to be a straight line.
That's to show. Okay, yeah.
Does that make sense?
Yeah.
So like they're vertically opposite angles.
Yeah. Okay. So you don't know that without knowing that those two are actually equal. So,
Yeah.
Okay.
Well, wait, the parallel because like
you know the parallel, so that's important.
yeah, that's
Yeah. So the parallel, so you got one set of equal angles already.
yeah.
So you know that HAG is equal to GA prime O. Because
HAG.
so you know that.
Oh yeah, good. That's a good starting point. So that's one angle, yeah.
Yeah.
So what color should I use? I'll use the black because black is the proof color right now, yeah. So this angle is equal to that angle, right? Yeah.
Yeah. You only need one more angle.
Because so this angle is equal to that angle because this line is parallel to that line, right?
Yeah.
That's a right angle. Yep.
Yeah.
All right. Good. Yeah. So you're gonna. I think it's gonna be a little bit tough doing angles.
Yeah. We're doing the length.
Yeah. Remember we have this. Remember this theorem we had?
Wait. Yeah. That's 1 to 2 ratio.
That's this length AG is twice the length of GA prime.
Yeah.
Remember that?
Yeah.
Yeah.
Oh. And then okay.
So then we can do SAS. We can try for SAS, right? What's the other thing? What's the other thing in SAS? Yeah, so it's OA prime, right?
Yeah.
So you need to show. So we already know that GA prime is equal to 2GA prime is equal to AG, right?
Yep.
Oh, so divide
So we want to
two.
show that 2OA prime
OA prime.
is equal to what?
And yeah.
Equal to AH, is that right?
Mm.
Is that what you're trying to show?
Yep. Kind of.
I mean, AH and A
Kind of yeah. Like,
dash OH are alternate angles and they're parallel. So AO.
you don't know if that positive like.
You don't know this is straight. So this is what we're trying to prove. We're trying to prove it's straight by showing that. So we've got this, yeah. We're showing that these two triangles are similar by SAS. We got the angles as well, yeah.
Yeah.
So we got that angle HAG equals angle OA prime go. And this is alternate angles, yeah. We have these two things.
Okay.
Yeah.
Wait, if you
Yeah, I guess maybe like there's ways of seeing it might be true without knowing like varying degrees of certainty. So you said something similar before.
Can we find a way to prove like HG is perpendicular to like AH?
yeah, you can
HG.
cut to similar triangle.
Alright, where's the similarity? You need the similarity.
Yeah, so to show this one, for example, right?
Yeah.
Can you see that basically because H prime is equal to O,
Yeah.
right?
Oh yeah.
So if you think of this as H prime, right? Then you're really showing that OH prime, so this is like OH prime, 2OH prime is equal to,
No, it's
sorry.
H prime.
Oh.
what am I doing?
Yeah.
Two H prime.
2H prime A prime.
Yeah.
This is more suggestive, isn't it?
This
Yeah,
makes sense
yeah,
because like the important stuff is similar.
The important stuff is similar, right?
So AH is like and then
Like the orthocenters of the triangles are, and it's relative to the same sides which
Same
correspond.
side,
Yeah.
so then they're in the same ratio. They're
Yeah.
similar.
So that's how they justify. I mean, that's really believable.
Yeah, that's believable. I'm assuming if you just like draw out like without the other stuff, you can find like a way to prove it easily.
Yeah.
Yeah.
Okay. So therefore, the triangles are similar, right?
Yeah, and they're just similar. Then those two angles are equal.
So can we check that they're the corresponding
And
angles?
HGA would be
Yeah,
equal to
because
OG.
So they're the ones opposite O. They're the other one opposite the OH.
You know that,
Yeah,
like,
They're the ones
opposite-
opposite this,
AH
right?
and OH, yeah.
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 So then they're equal vertically opposite.
So they're
of the-
equal. So then this is a
straight
straight
line.
line. Okay. That's pretty cool, isn't it?
Yeah.
Oh, finally. And that's called the Euler line.
Yeah. Can we try to justify that? Like,
Huh?
without, is there a way to justify it without like,
I was saying
saying that?
something like that.
I think you probably can.
Or you could just prove the fact as well.
Mm.
As in like
Yeah, like the way you prove it.
like you could actually just prove that if two triangles are similar,
Yeah.
then the distance between the orthocenter and one of the sides is in the same ratio.
I think the way like if you just like say if you have like if you extend this over to here, then this triangle like parallel. If you extend a parallel line from like the orthocenter to like the side, and then you have that this triangle is like similar to this triangle here.
Yeah.
And then that will be similar to this triangle here, which will be similar to this triangle here.
Oh, you know what? I just thought of another thing.
Hmm?
Because I'm crazy about that area. I think it might apply. Because the area of the triangle is that. Oh,
Right.
oh okay. Well. Okay, it doesn't quite work.
Would be nice if it did.
Okay, maybe that could be an exercise. Yeah, write that down.
Oh,
You just showed it, right?
yeah.
Oh, what did you say, by the way?
So if you extend h, like if you extend h, like,
To the vertex.
if you
to the
go
next one?
parallel, like parallel from h,
Yeah.
parallel to like the bottom line.
Oh, the bottom line, yeah.
Yeah, and then you'll have that like a and then that triangle made by AH and that like point is similar. Like if you drag it down.
Hold on, but how do we know it connects to G?
Oh wait, here. Oh. I see. Yeah. How do we prove that?
But yeah, anyway, it seems like you guys are on top of it enough to do the I mean, obviously we believe it's true.
Yeah.
I think it's a simple exercise, if it is an exercise at all, to show that that's half that, right?
Yeah.
That's twice that. So maybe you can make a note of it.
Oh.
Actually, maybe I'll make that an exercise. I'll write that
Yeah.
up as well. Okay. We're doing pretty well, guys. See, like, without all the distractions, we're
We
like
still got an hour left.
we still got no left, and we've done
Both of them.
almost both. So there's this comment I didn't read before. I was hoping you guys could just take me through it. Oh, by the way, I should state the theorem first, okay? So, can you see also? By the way, another reason that this is good to prove that they're similar, is that we get another ratio is 2 times the other one, right? What is it? HG is 2 times
OG.
yeah.
Yeah. Oh yeah.
Yeah?
Yeah.
So that's the theorem basically. Let me just say what they say, even though it's like the same, yeah. So the Orthocenter theorem is theorem 1.71. The Orthocenter, Centroid, and Circumcenter of any triangle. We didn't prove that, by the way. You notice that?
Oh, G.
Oh yeah.
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 And also
Alkalinia. The centroid divides the distance from the orthocenter to the circumcenter in the ratio 2:1, yeah? So maybe the centroid
It's H1 too.
divides the distance. So it also tells you what the order is. It's not just collinear.
Yeah.
It's OG. It's H. Or maybe if it's outside, then 2 to maybe, I don't know. All right, centroid divides the distance from orthocenter to circumcenter in the ratio 2:1, yeah?
Yeah.
And just to make things more or less confusing, depending on where you're coming from, I'm going to write O for circumcenter here, H for orthocenter there, yeah?
Yeah.
And G a centroid. Oh, yeah. Actually, I really wish I learned geometry like this in high school. It's pretty cool stuff.
Yeah, like a lot of theorems, like the stuff you learn in high school isn't that interesting.
Because people are like, well, if we teach them this in high school,
What are we gonna
how would they? Well, they didn't teach this in uni either.
Yeah.
But it's like, well, can you build a bridge with it? It's like, well, if you can't build a bridge with it,
then
why are we teaching them?
Yeah.
So we need bridges, multiple bridges.
Well, I guess center of gravity.
Yeah. We need to also upkeep the bridges that we have. Major tourist attraction, these bridges. Alright. Maybe you can build some bridges out of this.
Triangle.
Yeah, center of gravity. You said that right. Oh, okay. I'm just slow, sorry. Yeah, it's like a in joke, I guess. Central joke. Alright, so we're good. Let's see what the next thing says. So I didn't really read this, so I was hoping the momentum would carry us through. Let us study the figure more closely. We have marked the point N where the Euler line HO meets the line
A.
Wait, the HO meets the line through. So P was meant to be the midpoint of this B prime C prime. Let's draw some stuff. This is C B, yeah. So B prime is here, C prime is there, yeah? So P was meant to be the midpoint. How do we get P again?
P was.
Oh, yeah, so we joined A to A prime, yeah? And it passed through at P, I guess.
Oh, yeah.
Or maybe we just assume it's the midpoint for now.
Oh, no, it is.
Yeah?
Because
Or maybe it's defined to be the midpoint.
For parallel, we just proved it first.
Yeah. Yeah, that's right. Yeah.
So that's everything.
Okay, so not only is this the midpoint, but A prime passes through. Yeah? Okay.
Like the parallel graph.
So the Euler line HO meets the line through P perpendicular to B prime C prime. Like this line, I guess, yeah? Yeah? Somewhere, yeah?
Yep.
Called N.
Oh.
Okay?
Yeah.
Some craziness right there.
Wait.
Yeah. So N is on the line towards the center of the circumcenter of that triangle as well, isn't it?
Wait.
That's the perpendicular bisector.
Perpendicular bisector of that. Where isn't the bisector of that where A prime like intersects because it's a parallel?
Yeah,
graph?
it is. I don't know why he did.
What?
Oh, because like
It's like this
What am I missing?
P. This is P.
Oh, is that P?
yeah,
That's
because
Oh, you've already joined it. Okay, sorry.
because that's the
My bad.
Because he said diagonals of
Yeah. Well, this looked more like the middle.
I don't know that it's not this good.
It was very much tried to be to scale. So P is actually already a point, yeah? So this is P, and then we're trying to join it. Oh, oops. To N, yeah? Like that. The three lines AH, PN, and A prime O. So AH is that one, yeah?
PN.
PN,
Then
yep. A prime O, yep. Are they going to say they're all parallel?
A prime O. Oh, okay. They should be.
So they're all perpendicular to B prime, C prime, right?
Yeah. Wait.
B prime. C.
You just need to prove Pn is perpendicular to AH or O.
So B prime, C prime is parallel to BC, yes?
Yes. So you just need to prove Pn is.
So they're all
perpendicular
like each one of those three lines is perpendicular to one of those two lines, yeah?
Yeah.
So they're all parallel.
Yeah.
Well, I don't know if that's what the conclusion is. Okay, yeah, that is the conclusion. They're all parallel, yeah? Okay. Maybe I'll write this down just to keep track of what we're doing. So P. I'll erase the geometry. P N A H, right? A prime. O parallel, yeah.
Wait, so this is a exercise though. Well, it's.
Oh no, it's part of the discussion afterwards. I didn't actually read it before just then, so I was hoping you'd carry me through it.
But this is just like.
The observations. I think they like his style is like says facts and then theorem, but the theorem no longer needs a proof. Because the facts sort of proved it on the way. But there's no theorem following. It's just a discussion about how hardworking Euler was. Maybe I can read that to you because that seems easy. The name Euler appears so frequently in many branches of mathematics, a few words about him are in order. Leonard Euler was born in 1707 in Basel, Switzerland. In 1727, so I guess he was 20. He was invited to St. Petersburg Academy in Russia. I wish I knew more about that. It seems very prestigious. In 1741, I guess he was 30-something, 34. He left for Berlin. Oh, so he's older than I am now. He left for Berlin to take the chair in mathematics at the Prussian Academy. So I guess academies are hard to get into, I suppose. He returned to St. Petersburg in 1766, so he's like 60 almost, and remained there until his death. Doesn't say very much. Just geographic information, I guess. Euler was a tireless worker. His activities enriching every field of mathematics. Wherever one looks, there is an Euler theorem, Euler's formula, or an Euler's method. Euler wrote 473 memoirs that were published during his lifetime, 200 that were published soon after, and 61 that had to wait.
What had to wait?
He's like euphemism for death.
That's
Moreover, he did all this under a severe handicap, for he lost the sight of one eye in 1735. So that means he was 28. 28, and the sight of the other in 1766.
I'm 59.
Okay. His skill in manipulation was remarkable, and his intuitive grasp of mathematics enormous. We shall meet his name again and again in our work.
How does he write?
I guess now every time you talk about Euler, you're just recounting this paragraph.
Yeah.
In like whatever ability you can remember it to.
Did he write anything else after 59 years old?
Well, he probably did.
Probably died.
Well, there were 61 that were published after he died.
Oh, I mean, did he write anything while he was blind?
He
Did he
wrote
write
what?
anything while he was blind?
Oh,
Future he did.
Because that's amazing.
Wait,
Yeah,
let's see.
pretty good if he did.
I mean,
well, I don't know. So partially blind. I don't know fully blind. There was a story about him winning some competition when he was either partially blind or fully blind. Maybe he was fully blind to make it more interesting. There's something about finding like the equilibrium points of gravity. Like it's like a 2-body problem kind of thing, 3-body problem.
Oh, okay, yeah.
Like you have 3 things acting under gravity
Yeah.
or 2. I can't remember, but there was some stationary solutions or some special cases.
Yeah.
And I think he got basically more than anyone else and just missed something. I can't remember the details. And he won the competition while he was blind. Oh, well, he's definitely partially blind, but possibly fully blind. Yeah. It's sad that I haven't actually read anything direct and I'm just recounting other people's stories of him, which may or may not be true.
Is that you or the person?
Well, I'm now adding. I don't know what the person's doing.
Oh.
I'm telling you what I'm doing.
Oh, okay.
And I suspect people are doing stuff like this. I don't know.
Just go to Wikipedia.
I don't know, because people kind of over attribute stuff to people
Yeah.
when it's easy. Like, yeah, but anyway, I mean, it's. I feel like it's a fact that anyone who's super highly rated is overrated. Doesn't mean they're bad. They're probably still very good, just not very, very, 10 varies instead of 9.
Oh,
And if someone's considered to be rubbish, they're definitely underrated.
Yeah.
I think this is generally true. Anyway, so, but yeah, it doesn't, and someone who's that highly rated must also be very good, even if you're overrated. Yeah.
Yeah.
It just seems likely. All right. And yeah, and the genealogy thing, everyone's descended from Euler.
oh, yeah.
I guess that's pretty convincing in some way. But then he could be like the only one who has like formal students and stuff. I don't know. Okay. Okay, keep going. So since AP equals PA prime, AP equals PA prime. So it's bisecting, right?
Yeah.
I already said that. They are evenly spaced.
What
Isn't
Right.
that?
Uh,
So PN is so they're saying it's parallel. So the 3 parallel lines are evenly spaced.
oh. Oh yeah, because wait, if that's like
Because any other intercepts must be the same ratio, right? Because that's the 3 parallel line theorem, yeah?
yeah.
Intercepts are in the same ratio.
Oh. Wait.
We talked about this last week as well.
Wait. Oh.
In a different context that makes it hard to relate. Like anytime you have 3 parallel lines, right?
Oh.
Like
Yeah, that makes sense.
the ratio A to B is the same as the ratio C to D.
Yeah, that makes sense.
Yeah?
Yes.
So you take CD to be the perpendicular distances, right? And AB to be the diagonal, we just said, is bisected.
Oh.
So they're equally spaced.
Yeah.
You know what I'm talking about?
Yeah. Oh yeah.
So because A equals B, right?
Yeah. And then so
Then C must equal D.
Yep.
Okay. And if this is the perpendicular distance, then they're equally spaced.
That makes HN equals N then. Is that what you're saying?
Wait, what are you saying?
HN equals N, is it?
Oh, I think you might have spotted something, yeah? So HN equals NO. That's a
Yeah.
good conclusion, yeah. I think that's what
That
it
sounds
is.
easier than like
So
they're
N is
equally
the,
spaced.
well, I mean,
Isn't that what they meant by equally spaced?
Yes. But like
What
it's
do
easier.
they mean when they say equally spaced?
the lines are equally spaced. Like, I mean, the
Yeah.
perpendicular distances.
I thought like
Yeah,
equally
yeah.
spaced were
Isn't that-
triangles or
doesn't that just
something.
mean that,
I don't know.
Well, is HN the perpendicular distance? Are these perpendicular?
Well, is that perpendicular?
I mean, is HN perpendicular to AH?
Yes. Once you prove,
Yeah,
once you prove that.
I think so, right?
The-
Is that obvious? Did we prove that?
Oh, well,
from
the parallels,
the distance.
the parallel, right? So, because
What's parallel?
we know that like
BC dash is parallel to.
Hold on.
is HO
Well, we don't. What do we know about HO? This is the Euler line, right? So we can't really know that much about it because we didn't really know there were even a line before.
do we know HO is perpendicular to like
It's temptation to say that's parallel to that.
Yeah.
Where have we seen that before? Okay, but anyway, like,
but like if you prove that,
do we agree that HN equals NO, even though it doesn't look like it in the diagram?
no, but if you prove that these are equal, shouldn't it follow that they're parallel? Like if you prove that these are similar, it should follow that they're parallel, right?
where why parallel
to that
specifically?
No, but we know they're parallel. We know the vertical lines are parallel, right?
Yeah.
The question is if HO is parallel to, so that's not obvious.
Definitely not. If the wait,
Where if the perpendiculars are parallel, how do we know that they are distances are like equal? How do we show that the distances are like they're equally spaced?
Oh,
I mean,
okay,
equal. So basically, I mean, the thing is, we have three parallel lines, right?
Yeah.
And we have this has the same intercept, yeah.
Yeah. Oh.
So basically, any other line will have the same ratio. It just so happens equally spaced. I feel like it's the one that has the right angles, right?
Yeah.
And then HO might be another one where it intersects at N.
Yeah.
At this point, I mean, either case, it's still equal, right?
Oh yeah, and the AP equals P A dash.
yeah. So that's
yeah.
like,
Excellent.
it's
Yeah.
kind
Yeah.
of
So
similar.
so this is the AP, right?
Yeah, that's
So
the
this-
AP. That's the
So
AP,
this,
and that's the
so
P A
this
dash.
is like A dash, and this is P,
Oh yeah,
right?
then that makes sense. So then.
This is like the point that makes it equally spaced, and this is the conclusion that we want, I guess.
Yeah.
Maybe
Right,
going
then
through a
why
different
the other
point.
line?
Yeah, it's going through like this point.
Yeah.
Like that.
Yeah, and then something like that. Yeah.
You know what I'm saying?
Yeah, and then the idea is there. Yeah.
Yeah. So we have three parallel lines,
Mm.
and we show that one line going through them has ratio 1:1. So all of them must have ratio 1:1.
Yeah.
And they don't have to meet at that point. You know, you could just move them around because that's the nature of.
HO really seems like parallel, but
Yeah.
I don't
This
think-
is my fault, I
feel like
think.
it's not. It probably isn't.
I mean, why parallel to that specific line?
It's probably not.
I mean, like, H looks parallel to BC.
seems parallel.
Well,
That's
I
too
don't-
specific.
I don't think it is.
It's definitely not.
Definitely not.
Because if you apply from another side, then it will be like you could apply from another side,
Like AB.
and it would be parallel.
Oh, yeah, that makes sense.
It can't be parallel to all three sides. So
That makes sense.
It's too
Oh,
specific.
but it could still be parallel to one side
isn't necessarily. Would it?
because it has to be like this way.
Yeah.
Anyway, so let's just we think about that as an exercise. Let's see what they're trying to go with this train of thought because I don't think these facts by themselves. Wait, maybe that's the end of it. What's it say? Hence, N is the midpoint of the segment HO.
Oh, okay, yay.
Yeah.
I have assumed that it is parallel.
We have conducted our discussions with respect to the side B prime C prime of the medial triangle A prime C B prime C prime. If we apply the same reasoning to either of the other sides, and this is, I guess, something related to what you're saying, the line segment HO remains fixed. Oh, interesting.
HO. Oh,
HO remains fixed.
wait. So all of those like.
Oh, so you're saying, yeah, like HO, yeah, if it was parallel, it would be parallel to all the sides, right? It's
Yeah.
some kind of, oh,
So,
yeah, okay, let me just unmove this. And is bisected by the perpendicular bisector of the new side. Oh, so that's what it's saying, is it?
bisect the
So
yeah,
that's the perpendicular bisector.
and the
And
other
every
ones.
perpendicular bisector
Yeah.
bisects it, yeah?
Yeah.
So it
So
must be the
that's the
circumcenter.
Oh wait, Jesus. Why everything is tied together?
Oh.
Oh.
Actually, this is gonna be the next one's gonna be so sick that like
I think
What?
I
Next
think
one is-
9 point question.
yeah the next one's 9 points. There's 9 points that lie on the circle.
Yeah.
What's
Okay.
9%? What the hell is that?
Well, that's what we're gonna explain.
yeah,
Go to
every-
that
all,
now.
like all of the stuff.
So 3 points on triangle.
Well, the thing is, I think we have enough time.
Okay, that's good.
We have enough time to go through it.
What should I search for?
Hold on, let me just finish. So in other words, N must be the circumcenter of
A.
triangle A prime C B prime C prime. To summarize, the circumcenter of the medial
sorry,
triangle
I'm
lies
sure
at the
it's not A, it's
midpoint
just
of the
a
segment HO of the Euler line of the parent triangle. Also, the triangles are similar.
You wrote this down.
The circumradius of the medial
Right.
triangle is half the circumradius of the parent triangle.
Oh, word. Half the
Yeah.
radius of the bird, right? Wait,
Yeah, that's because it's similar. Yeah.
yeah.
So half, everything's half. Okay. So the end is the circumcenter.
Yeah.
And the distance to all these points are half the distance to these points.
Yeah.
Okay.
Oh, yeah.
Yeah. All right. And then Euler appears to frequently in so many branches of mathematics. So that's the end of the chapter, okay?
Okay.
There's 4 exercises for you to try. Okay, the first one is interesting because it kind of reflects what we observed, right? By drawing a new version of the figure based on something else in the book, instead verify that our proof works when the triangle is obtuse. Yeah.
Oh God. Oh God.
But this is not for now.
Thank God.
Says the person trying to derive the cubic formula.
I stopped trying. I mean, I want to solve that.
No. The point is not to stop trying that. The point is to start trying this as well.
This is basically a, like,
All prefer will stop trying that instead and do this instead.
If you can do B, if you can try an impossible, why not try to
it's like proving 1 + 1 is 2. You can
Okay,
do
so
it.
I guess the hardest part of this next chapter is to draw this diagram, which involves.
Oh my.
Oh no.
Oh Jesus.
Wait, we're doing
Which
it.
points are there?
Hold on.
Tell me it's less than 2 lines.
It's a little more than 2 lines.
Okay, so the feet of the 3 altitudes of any triangle. What does that mean?
Obtuse, even obtuse triangles.
Yeah, so the feet.
It's like
Yeah.
A down, like AH down to
So the
B.
green line points, yeah.
Yeah.
So that we should I draw them in?
Do you want to use the same diagram?
So this was called, is it E, F, and D? D, E, F, yeah? So these are called D, E, F. I have to use the same diagram. How can I reproduce this?
Just take a photo.
Yeah. Remember, it was that Taj Mahal thing? It's like they cut off my hand, so I never do something like this again. It was like, yeah, like the guy built the Taj Mahal for his wife or something.
Oh,
Yeah.
And he cut off the guy's hands after he built it, like the architect or whatever, or like builder. I don't know how why the hands. Maybe he had to draw it or
So
something.
it would be unique.
So he would never be able to build something as good.
Just make someone else do it. It doesn't do.
But he was the greatest of the greatest, and he built the greatest thing. And then you.
Your
disable it.
purpose has been served.
Yeah.
It sounds really like. I don't know. It's actually really cruel and
Yeah.
hard.
I mean, it's India after all.
Hey, guys, don't laugh. Frown. Frown. Okay, so D, is that D? And then E is this one here. And then F, let's just imagine there's an F somewhere here, okay?
Why?
Imagination is powerful.
Wait, why is that over there?
Oh, because you know
It's the altitude from here.
Doesn't
Oh,
that-
that's why you gotta imagine.
Imagine it's
If you actually think about it,
It's wrong.
okay, it's here, yeah? F. It's so close that you want to just draw it.
You wait.
But I know I'm gonna regret it.
You
Because
wait
then the
till
lines, there's too
everything's
many lines.
Yeah, one that's one, like you put that line in, let's do it.
Okay. So the feet of the 3 altitudes of any triangle.
Why the feet?
Huh?
Wait,
The
feet or feet?
The feet of the 3 altitudes of any triangle.
You mean feet?
Wait.
So the altitudes was pluralized.
Alright.
Anyway, so D, E, and F, yeah?
Yeah.
Maybe I can erase this stuff now, some of it. Oh, jeez. Again, this is getting epic. And this is obviously too epic to be
What's your even?
contained in, it's as much epicness that can be contained in one chapter. Okay. Right, so D, E, and F, yeah?
Yeah.
Alright. The midpoints of the segments from the 3 vertices to the orthocenter. So the midpoints of the 3 of the segments from the 3 vertices to the orthocenter.
Yep.
So the midpoint of AH, yeah?
Yep.
Alright, what should we do with that?
L, M, and okay.
Yeah,
and M.
that's what they did. So K, L, and M.
Yeah.
Okay.
Well,
This
we
is
only
K.
need
Yeah.
and that's M. Because we don't want to put in L because that's
This is L.
but L is confusing. So use M because
Well,
we
what's-
have to pretend the other one's L.
Wait, hold on.
Oh, unless you have to stick to the diagram.
I want to stick to the diagram just in case,
Yeah.
Well, yes.
because this is getting out of control.
Yeah.
And then the other one we didn't even draw, right? That's how out of
just
like
imagine that.
here, yeah.
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 What are the other 3 points? Are you ready for this?
And there's another point, say here, right?
If you're wondering what this is building up to, think about the fact that it's called 9-point circle.
There's only 6 points,
and
and only 3 of them are the same color.
Oh crap, we lost it.
Okay.
Oh, that's great.
Are you ready?
I just feel like ABC.
Are you ready, kids?
That's not easy.
The midpoints of the 3 sides. So where do you have that?
Oh,
B prime, C prime, A prime. Yeah.
Yep.
So actually, we know more about the circle than when you think, right? We already know about the circle that passes through.
You're telling me is it's all but a circle.
let's see.
All lie on the same circle. Boom, boom, boom.
That's a
Where's the black?
here.
Yeah.
Again, I'll try not to smash the computer.
Remember when we proved that any 3 points lie on a circle? That it's
Any
hard
9
for 4
points.
points to lie on a circle.
Yeah.
So I guess it's kind of
9.
artificial. Some of the points are a little bit dubious because I feel like you just got the circle and intersected stuff, but then you found that there were nice points of intersection or something. But all lie on the same circle.
Oh, doing
I
it.
have to say it like this or Sean will fall asleep.
Okay, let me see.
Ah.
Seems legit.
So we know A prime, C prime, B prime, C prime lie on the circle with center end, right? We knew that from the end of the last chapter.
Yeah.
So K N
Oh,
L
yeah,
N
yeah.
M N.
And then we know that what are those things again?
And then you got the medians.
Oh,
How to find that point.
okay, and the radius is half the circumradius. We know that already, right? Radius, because it's half the it's similar and it's half the size of the big triangle. Yeah. Okay, so we know that. We know these 3 lie on the same triangle. It's a matter of showing the others lie on the same triangle. Yeah.
Yeah.
And again, they do lots of the proving before they state the theorem. But I thought I would save you the
Suspense.
euphoria. Yeah. Apparently, suspense is bad in mathematics because people get lost way before you get to the punchline and they don't know what you're talking about.
Well, we can just prove that like A dash B dash C dash D F are on the same circle, and then we can prove that like they bisect A H B H and C H.
Yeah,
That works. Yeah.
that works. QED. No. Oh yeah, I remember. This is actually quite nice. Okay. How to do this? Yeah, it's a huge technical difficulty to draw this diagram.
It's a circumcenter.
And back in the 70s, this would have been like you had to draw this by hand.
Yeah.
This is
It looks like it wasn't drawn by hand though. It probably
This is the
was.
circumcircle.
Huh?
The circle that they lie on.
So the circle of B prime, C prime, A prime.
Is the circle they lie on. Right?
Yeah,
So
because it's unique, right? There's only
so you
one
think they
circle that
found
passes through any.
this-
Huh?
You think they found this by like just drawing the intersection and everything in and then
Yeah, well,
okay.
I guess. Yeah, and then you kind of build it up
Yeah.
by saying it's
Yeah.
9 points.
That's not good.
Yeah. I guess, can we make it intersect another point and then call it the 10-point circle? The 11-fold circle. Way. 8. Oh no, that's only 8. All right, so. Yeah. Okay. Since BC is a common side of the two triangles ABC and HBC, HBC. Oh, that's not a. Maybe it is time to draw that line in. Alright, be brave. Oh, I didn't pass through him. Damn
Good enough.
it.
Connect the points and go like.
I'm drawing the circles.
The proof is just me drawing a circle with a passes through the It was like perfect.
Yeah.
Actually, I think you would accept that better than an actual proof.
Yeah.
Because that would be just so unlikely.
Like, what is the chance it works after all this?
And what is the chance the proof is correct? That you think the proof is correct? Like, what it's wrong if you think it's correct? Okay, so since BC is a common side of the two triangles, ABC and HBC, whose other sides are bisected by C prime, B prime, and L. Yes. Both segments C prime, B prime, and L prime are parallel to BC. See, that's the thing. Like, if he just says the conclusion first, we'd probably be able to see it ourselves.
Yeah.
But so he says the reason and then conclude the thing he wants to say.
Yeah.
So the conclusion is BC is parallel to B prime, C prime, and LM. Yeah. So we know that it's parallel to B prime, C prime.
Yeah. We it's clear enough that it's parallel to LM as well.
Because
It's
it's half of the HCB. Like
It's the midpoint of HCB. Yeah.
and
Oh.
CHB share. So then similar by like half.
Oh.
Yeah.
Oh, because these are the midpoints.
Yes.
So they're parallel, right?
Yes.
Should I join that line in? Oh, risky.
Oh, and then the like cyclic chord or something.
Cyclic quad.
Oh wait.
Oh.
Yeah. No. Wait. They're equal in length.
What's equal length?
Actually LG, LM and BC, B prime, C prime.
L.
They're both half of
LM. Yeah, so LM is half.
CB and
And
Oh.
since wait,
so then it's
I see.
but that doesn't prove that.
So they're equal, right?
Yeah, so
I'm gonna draw something in.
Yeah,
Wait,
so
that means they're cyclic.
they're either parallelogram.
Well, it's definitely a parallelogram, right?
So now how do we?
It's
Hold on.
cyclic. Oh,
No, it's cyclic. Yeah.
Bro, we had this exercise about cyclic parallelograms.
Yeah.
They're not all rhombuses or whatever.
Oh,
Alright, so should I draw the quad? It's about the quad, the next thing.
Just do it.
yeah.
But if I draw it,
It
there's no going back.
Doesn't matter, just do it.
Alright, let's draw it in black. But that doesn't mean it's parallel to that line.
Draw LM first.
Maybe I'll draw in blue.
No, but it is parallel. That's what they said before.
No, it's parallel to that side.
But HO is parallel.
Is HO parallel?
They said
Yeah,
last time.
HN is parallel. Wait.
We never agreed to this.
We
They
never
said
agreed to
the book said it.
Didn't
You
I?
did?
Yeah.
No, I don't believe you because I read the book aloud and only you retained that.
Because you don't pay attention.
Actually, I do admit you do pay the best attention. Okay, so let's go.
Big easy.
Draw LM.
Alright, let's do
Yes.
it, guys. Guts and glory. No guts, no glory. And then like it's just so difficult to draw this line in. I mean this one is not that blue line, but it's this blue line, guys. Maybe I'll make it black, because then there's no confusion on this side.
Then I have to prove that this is a rectangle. Sure.
So
It
insightful.
might be a rectangle. You never know.
I think it's a
supposed
rectangle.
to be.
And this diagram
Yeah,
is
it's a
the
rectangle.
most to scale
mean,
diagram
it's
I may have
supposed to-
ever drawn.
Yeah.
If it's
And it looks like a rectangle. Okay. So therefore, it's a rectangle.
Yeah, it has to be.
Apparently, this rectangle. You have to prove it.
It has to,
Are
because
you reading from something?
it's because it's a cyclic quad, right? So then, if it's a parallel, if the two
Wait,
sides
do we know
parallel-
it's a cyclic quad?
From the
it's
fact
supposed-
that it's a 9 points.
well, it's
Oh,
supposed
it's meant to be. Okay, yeah.
It's
So
meant to
then,
be, yeah, sure.
Okay, if it's a parallelogram,
And if
then
it's
it has to be
parallel.
a
yeah.
rectangle, right?
Yeah. Okay.
All right, good reasoning. That's the same way we do the inner circle stuff, right? So you assume it, try to see the consequence, and then we have to prove the consequence, right? And then consequence actually build proves part
So
of
then L and C are
So
the
L,
points.
M are now part of the
So
5
LC
points.
is a
Yeah, that's what,
diameter.
ah,
LC is
is that the reason?
like,
Yeah, so LC would
Because
be
like that would mean L, N, and C are on like 1 point.
yeah.
Yeah,
What's do you
LM.
want to figure out why it's a rectangle yourself, or do you want me to go?
keep going.
I'm going Wikipedia when I get to it.
What? Well, you don't have to because we can finish it here.
I mean, Wikipedia is like probably gives like.
But it doesn't explain.
It's like,
It's like
Wikipedia is probably more reliable than you.
I mean, it does have a better image.
What if you wrote Wikipedia page for this?
It's like then it would just be dramatic irony.
I'm gonna go to Wikipedia.
YouTube that. You check out that article. And then I start just quoting the article.
Yeah.
They probably quoted like this order thing from Wikipedia.
There was a story where this guy was like he was at a like party, and then some other guy was like talking to him about like something that about like this concept that like that guy pretty much had no idea about.
Yeah.
And then he was quoting an article, right? And then but then like the guy was like the main guy was saying how he was misinterpreting like quote. And then so then the guy didn't believe him, right? And then he called like a bunch of women to call him an idiot. And he's like, hey, what's the article you're like? What's the article you're quoting? He's like, that one. He's like, okay, search it up. And like he searched it up, and like, who's the author? And like, it was him. And, like he's just saying that he's telling him he's misunderstanding his own quote.
So that's pretty fun. All right. Let's see. Oh my gosh. Oh my gosh.
So many words.
It's I can't actually read English. It's just difficult. Similarly, AH is a common side to the two triangles BAH and CAH. Blah 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 blah. So therefore, C prime L. You got to read the conclusion because then you can just figure it out yourself, right? C prime L and B prime M are parallel to AH.
C prime L
AH.
C prime L
and B prime N. This is better diagram paper.
I think it's in here B prime L and
okay.
So I think it's the same thing, but to the other, we're just similarly doing it for the others. So we'll probably get 3 rectangles. Yes.
B prime L and
B prime L and
C prime M
C prime M.
AH.
Are they parallel?
Yeah.
And they
Oh, what is that? No, we're saying C prime L and
But
B
like
prime N.
we drew the diagram wrong.
C prime L.
It's
yeah.
not very
It's not
parallel.
parallel
It's
to
not parallel to AH.
Oh, I think we drew it out.